Hi everyone, thanks for checking out this video. So in this lesson, we're going to continue adding some more functionality to our tensor type that we're working on. And it's going to be a pretty easy video because just like in the last video, a lot of this will be just like copy and pasting things we've already done for our value data type and just making a couple small changes to get it to be appropriate for our tensor data type now. So yeah, before we get into like the real like neural nets and stuff, just a little bit more to do in terms of adding some like basic functionality to our tensor data type. Okay, so this is all the code from last time. Sorry, not just last time, but like all the code that we have so far. I also organized it now so that it's split up into like the value code and the tensor code, just to make it a little bit easier to find things that we're looking for. So yeah, just make sure you have this at the top of your file and just run this so we can use this stuff. We don't really need the values for these coming videos, but we do need this operation data type, and then we need our previous tensor code, which was the tensor type definition, and then the constructors for the 2D constructor, and then the 1D constructor if we're making like a row or column vector. So yeah, just make sure you have that at the top and run that so that we can use it. And okay, let's get into it. So the first thing is we want to be able to print out our tensors and like take a look at them. So just like we did for the values, we're just gonna grab copy and paste this code that we had for values, this overriding of this show function in like the base Julia function. So we're just gonna grab that, and then yeah, basically just gonna make a couple like small changes to this. So what we're gonna do is just change this to be tensor and then type tensor. And then just change this to be tensor. Oh yeah, and then this also. And that's basically it. So this should hopefully allow us to like print out the sorry, not the values, but like actually print out the tensor. Yeah, so maybe I'll actually just grab some of the test code from the last lesson. Let's grab this from the last lesson. And then so now we should be able to actually like define this tensor x and then actually print it out without getting an error. So yep. Okay, and then just to make sure, this should also be just checking the size here. Just making sure that it's actually two-dimensional, even though it looks one-dimensional. Yeah. So this is again like a row vector, so it's technically two-dimensional. It's not just shape 3, nothing. It's shape 1, 3. But yeah, it's just to check for what we did last time. Okay. Next thing to do, we want to set it, but so we're eventually going to be doing this like backprop function again. You guys remember how for the values we did all these different backprop functions to define each step of the backward pass for every operation. But before we did that, we had to write this line here, just saying like, okay, if a value was not created from any operation, that's what this value of op type nothing means. If the value was just defined by the user and not created from an operation of other values, then the backprop function, when it sees that value, just does nothing. So we need to now copy that line for our tensors for actually the same reason. Just when we eventually do this backprop, if we see a tensor that wasn't created from any operation, then we want the backprop function for it to do nothing, basically. So we're going to say backprop, just make the name make sense, just make this say tensor, and then tensor, if it's op type nothing, that means it wasn't created from any operation of other tensors, it was just probably defined by the user. Then the backprop function will do nothing. So yeah, it's just kind of something we have to do before we start eventually doing this backprop function that we're going to do more of in the coming videos. And then next, we want to be able to check if two two variables are pointing to the same tensor. And so it's the same thing we did for the values, but when we do this comparison, we don't want to just check if they're storing the same number. We want the equals to only return true if they're actually referencing the same object in memory. We don't want two values to be, or sorry, two tensors or values really to be considered equal just because they're storing the same number or the same array of numbers. We only want them to be considered equal if they're pointing to the same object in memory. So yeah, just going to copy our value code, and again, just change a couple like easy things just to make this for tensors. And yeah, so for that, that's all we need to change. Yeah, okay, so we're good for that. A couple more things. I'm gonna start doing a new block now, actually, just to keep things separate a bit. Okay, so now we're gonna add a couple more cool things to just make some things easier on us. And like these parts, the next 3 lines I'm going to show you guys are things we have not seen before from values. So these will actually be new things for the tensors. Okay. So just to show you guys something, so the first line is we're going to say base size, taking in some input x, which is a tensor. That's going to equal the size of x dot data. So what this is going to do is this is going to allow us to print out, like rather than having to print out here the size of x dot data, this will allow us to just print out the size of x, where x is a tensor. So now after this, we'll be able to call this size like base Julia function directly on the tensor, like here where x is a tensor, and then have it actually work for us. Okay, and we'll test out all these lines in a second, but yeah. So the next one is going to be base dot get index, taking in an input x where x is a tensor, and then the syntax here is just comma I period and parentheses. That's just what the syntax is to override this base function here. And then this is going to be get index parentheses x dot data I period. And so this is going to allow us to do like indexing. So this will allow us to do things like if we want to get like the element of the tensor at like the 3rd row and the 4th column, rather than having to do x dot data 3rd row 4th column, rather than having to do that, we'll now just be able to call it directly on x, and it'll know to look at the x dot data to actually get the value here. Sorry, maybe I should be saying element because we called our previous data type values. Yeah, to get the element at this index. And then one more line that's going to be a little bit similar to that. So this one is going to be base dot set index exclamation point, taking in an input x, which is a tensor, comma v, comma I period, and parentheses. And then this is going to be set index exclamation point x dot data v I period. And this is going to allow us to do something similar, where if we're setting an index to be some specific element that we want to change, like we want to make this like 4. Sorry, it should be actually float. But yeah, we want to make this 4.0. Rather than having to do x dot data to reset it, now we can just do x and then the index, and this will know to change x dot data. Okay, so we can run those, and then now do a little test to test like basically all these things. So I'll just say yeah, x equals tensor parentheses, 1.0, 2.0. Remember, these have to be floats. Might change it later to make it more robust, but for now, yeah, they do have to be floats. 3.0, 4.0. Okay, defining a tensor. Can now print out the tensor. Print out the size of the tensor. Remember now we don't have to do x.data. We can just print out the size, and this will give us the size of x.data, which is also the same as x.grad because they should have the same size. And yeah, should be output, two rows, 2 columns. Now we can try changing the element at the second row and second column. Set this to be 5.0, and then we can print line x again and just confirm that it has changed. And then also just print out, just to show you guys this one working, the get index. Can just try printing out x 2 just to show that we can do this this get index like that. Okay. Yeah, looks like it worked. Looks like it did everything we wanted. Okay, so that's good. So I think that'll be it for this lesson. Basically a pretty easy one. Next lesson, I think we're going to start getting into the actual operations. Going to start getting into what will actually be used to make this neural network we're trying to get to. But yeah, this was just a little easy lesson, adding a bit of functionality to our tensor type. And then yeah, next video, I think we're going to do matrix multiplication for these tensors. Which, don't worry, it won't be as tough as it sounds, because like I keep telling you guys, we've already done the hard part, and now it's just a matter of doing the same thing we did for the values, but making it work for two-dimensional array arithmetic. Okay, so just to remind you guys, all these lessons are up on my GitHub, and the link to it is in the description. And then also just to remind you guys again, this whole project is based on this SimpleGrad library that I made. So if you guys want to check out the actual library, this is like a real library that you can install and use in Julia. And then I wrote the documentation to be like a textbook so that you can read through and like understand how everything works. So yeah, this whole video series is basically like showing you guys how to make this SimpleGrad package that I made. Okay, so thanks for watching, guys, and see you next time.